Welcome to this presentation on a distributed denial of service attack, which is often referred to as a DDoS attack. The objectives of this presentation are to define what a DDoS attack is, to explain the legality of DDoS attacks, highlight common symptoms of a DDoS attack, to show how DDoS attacks are typically executed, to explain why DDoS attacks might occur, and to look at how DDoS attacks can be partially mitigated. So let's begin by defining what a distributed denial of service attack is. There are many forms of a DDoS attack, but the Oxford Dictionary defines one form of a DDoS attack as follows. A form of denial of service, performed by simultaneously sending large numbers of packets to the same host or network, from many computers in different locations on the internet, with the aim of flooding a network connection or other service. DDoS attacks are illegal, as shown on the National Crime Agency's webpage displayed. The webpage displayed makes reference to the Computer Misuse Act of 1990, which makes it illegal to intentionally impair the operation of a computer, or prevent or hinder access to a program or data on a computer, unless you are authorized to do so. So, now that you understand the legalities of a DDoS attack, and what a DDoS attack is, here is a list of some of the symptoms of a DDoS attack. An unexpected increase or surge in web traffic, particularly from an unexpected source. A flood of traffic, originating from a single IP address. A website starts loading a lot slower than normal. A website generates a lot of timeouts and errors. Increased server CPU and memory utilization. The website goes down. Now, let's visualize the stages of a DDoS attack, going from fully dormant to fully active. The overview now displayed shows the components of a DDoS attack, whilst the DDoS attack is in its dormant state. In the top left-hand corner, we have the attacker. Next, moving from left to right, we have a controller computer. This computer is typically primed to instigate the DDoS attack, and typically sits waiting for a go command from the attacker. In the middle of the screen, we can see two green computers that represent normal users, sending traffic to a system, which is typically the front end, to a database of some sort. The red computers are part of a group of computers that are collectively referred to as a botnet, and these computers all play a part in the DDoS attack, as we will see. What is shown here is a typical setup of a DDoS attack that is in a dormant state. So, now let's see a DDoS attack in action, where no mitigation is put in place. Stage 1 is where the attacker sends a control command to the DDoS controller PC, telling it to start instigating the DDoS attack. The attacker could instruct the controller to start the DDoS attack immediately, or to begin the attack at a certain date and time. Stage 2 of the attack is where the controller PC sends a command to the computers that are part of its botnet. These computers are random computers on the internet that have been infected with malware. Typically, the owners of these computers are not aware that they have been infected, and they could be hundreds if not thousands in number. Stage 3 of the attack is where the malware-infected computers, collectively known as a botnet, start to send traffic to a targeted system. Stages 4 and 5 of the attack is where the targeted system becomes overloaded with the amount of traffic it is receiving, and if the DDoS attack achieves its aims, then the system and the database will crash, and as a consequence, the service provided by the system becomes unavailable and denied to users. There are many reasons why DDoS attacks occur, but here are some of the more common reasons. Hackers showing off their computer skills. Seeking revenge upon a targeted company. Political reasons, someone doesn't agree with a regime. Financial gain, holding an organization to ransom. Achieving competitor advantage. Introducing a distraction for something bigger. Now that we have seen how DDoS attacks can occur, some of the DDoS mitigations are as follows. Vertical scaling. Horizontal scaling. Implementing a web application firewall. Improving network and host security. Now, let's look at each of these in turn. Vertical scaling. This is where we increase the computing power, so that it is able to cope with a massive increase in traffic. This diagram shows a larger computer handling traffic, and the system remains active and available to users. Horizontal scaling. This is where we employ a load balancer that will evenly distribute the traffic load across multiple computers. In doing this, assuming that there are sufficient computers, the load is spread, and so no single computer gets overwhelmed by the amount of traffic. It should be noted that some rogue traffic may still get through, as shown by the red arrows leaving the load balancer, although some load balancers also have an intelligent traffic filtering capability. Web application firewall. This is where an intelligent filtering mechanism, known as a web application firewall, is placed in front of the system's computers, and filters out any rogue traffic. It's worth mentioning here that some genuine traffic may also get blocked, but this is a small price to pay for the continued availability of the system. Let's now have a short recap on how a DDoS attack can be mitigated. Vertical scaling. Increase the computing power available, so that increased loads can be handled. Horizontal scaling. Increase the number of computers, so that an increase in load can be spread evenly across multiple machines. Web application firewalls. Use software and AI to detect and block suspicious traffic before it hits the company's systems. Improved network and host security. This can be achieved by installing anti-malware software, regularly applying patches, regular software upgrades, blocking unused ports, and disabling unused programs. Well, that concludes this brief presentation on a distributed denial of service attack. I hope you found it useful, and don't forget to check out the other information security tutorials available. And thank you for watching.